Hello everyone, welcome to Pratibha Tech. In this video, we will solve the problem of the day question on Geeks for Geeks for 28th February 2023. The problem statement for today is optimal array. This problem is based on arrays and sorting. So let's now open this problem. First we will understand this problem clearly. Here it is said you are given a sorted array A of length n. For each I, that is 0 less than equal to I less than equal to n minus 1, you have to make all the elements of the array from index 0 to 0 till I equal. Okay, so at any index of the I which is given, so we have to make all the elements equal using minimum number of operation. In one operation you either increase or decrease the array element by 1. Okay, so you have to return the list which contains the minimum number of operations for each I to accomplish the above task. Okay, so here it is said that okay, so first we will read it completely. So in note it is given that it is 0 based indexing. For each index you need to consider the same array which was given at the starting. Okay, given to you at the start. So here in this example it is said that n is equal to 4. That means total number is 4 there, and given array is 1, 6, 9 and 12. So the output is 0, 5, 8 and 4. So at any I, if you are looking at I is equal to 1, that means this one. So for that it is required, that means for I is equal to 1, that means for array up to this one 0 to I, that means 1 to 6, 1 and 6. 5 number of operations are required to make this array equal, that means make these two elements equal to some other number. So we'll just go through this explanation. Here it is said that for I is equal to 0 we do not need to perform any operation, as our array will be this one, our array will be 1 to 1. So the minimum number of operation will be 0. If it is only one number, so we do not have any number to go to, and that means since we have only one number, so we have to reach to that number only. So that it is said that no number of operations are required. For I is equal to 1, we can choose to convert all the elements from 0 less than j less than I to 4. So for I is equal to 1, that means when the pointer is up to this one, that means starting from 0 to 6, if we can choose to convert all of these to 4, then the array will become 1, then the array 1 and 6 will become 4 and 4. The minimum number of operation will be, for converting this 1 to 4, 3 is required, that means 3 number of operations are required, because here it is said in each operation you can either increase or decrease the array element by 1. So 3 is required, and to convert 6 to 4, 2 number of operations are required. So it is 3 plus 2 is equal to 5. For I is equal to 2, when it reaches 9, then we can choose to convert all the element from 0 to j less than equal to I to 6. So if we choose to convert all these elements, that means 1, 6, 9 to 6, then the array will become 169 will become 666. So the minimum number of operations required is 1 to 6, 5 operations, 6 to 6, 0 operation, and 9 to 6, 3 operations. So 5 plus 0 plus 3 is equal to 8. Similarly, when I is equal to 3, we can choose to convert all them to 8. So this one, so we will start with this array 1, 6, 9 and 12, but after some certain number of operations, all the elements will become 8. So the minimum number of operation will be 14. Here again the same thing, you can just subtract from each of them. That means 8 minus 1, 7, then 8 minus 6, 2, 7 to 9, and this one is minus 1, and here this one is 1, and here it is 2 again. So it will become 14. If you add all of these, then it will become 14. So here and the similar approach has been taken for solving this one, example 2 as well. So here what we can do, we can take the approach of solving it through calculating the median. That means we will calculate the median for each I. That means for each I, that it means from the array size 0 to I, and we can try reaching that median for all the elements, and we can simply count the number of steps there or the number of operations there. So for each element we will count the medium, and that means for each I we will calculate the medium of that size of array, and we will try to reach to that median, and we will calculate the number of operations we have taken to reach to that median. We cannot take any other elements, so that it would be optimal for the elements lesser than the medium and even greater than the medium. If you are choosing something on the higher side, then the number of operations for the lower elements will be more, and if you are choosing from the lesser side, then the same thing, the number of operations for the higher element to reach a lower value will be more. So we have to find the minimum element. So it is better that we find something in middle and we try to reach to that particular median element for each of the array element indicated by I. So for that, let's start our coding taking that approach in mind with the median approach. So what we will do, first we will create a variable called median, that is equal to 0. Then we'll create a long array for that response array that would return our output. So response is equal to new long array of n. Then we'll start our iteration saying for int I is equal to, we are starting with 1 and I less than equal to n, then I plus plus. See, we are starting with 1 for the same reason, because for this one it will already be pointing to that only. That means no number of operations will be required. So we are starting with the 1 so that we have something to go to calculate our median. So for this one, what we will do, we'll check if I modulo 2, that means what is the way to calculate a median? If it is a even number, then if it is I is equal to 4, this one, that means if any even number, then what we will do, we calculate that I by 2 plus I by 2 minus 1, these two elements, and we have to extract the and we have to divide that element by 2. See, because if there are 4 elements, then we cannot say that which one is in between. So we will take both the elements and we will divide it by 2. If it is odd number, then we can simply do that I by 2. Okay, so I by 2, so that will simply give something by something in the middle. So for that reason, we will be checking two conditions. If I modulo 2 is equal to 0, then median will be A of I by 2 plus A of I by 2 minus 1, and the whole thing has to be divided by 2, because now we have got 2 elements there, so we cannot take anything in between. So to get anything in between, we have to divide it by 2, taking both the elements, add it and divide it by 2, so we'll get a median. Else, if it is odd number, that means if it is odd number, then simply if it is the size is 5, then if we divide by 2, it will simply gives that second index array. Since this index is starting with 0, so 5 by 2 it will give 2, so it will be actually the third element. So in the array of size 5, actually if you look, then third element is the median of it. If you are looking at this one, if you look at this one, then this element, this one is the median of it, because only 5 are there. Okay, so I hope this one is clear. So this one, for else we'll do, what we'll do, we'll write median is equal to a of I by 2. So once this is done, once we have calculated the median, then what we will do, see, we have to reach for all the elements, that means all the elements in up till until this I is that this index position I is there, we have to make all those elements from 0 to I to median, that means we have to reach to median. So for that one, we have to do some certain number of operation for all the numbers there, and we will simply count them. So for that, we will initialize another variable here, int I is equal to 0. This iteration is for reaching to median variable for all the elements up to I. So this will be there, and then j until it reaches I. So we will do for those many elements. Then we will simply increment j here. So now here what we will do, we will do math dot absolute value of median minus a of j. That means in this step what it will do, it will calculate a difference between median and each element up to I. So if you have got some median here, then it will calculate the difference between 1 and that median, then 6 and that median, and it will simply it will calculate for each one. And what we need to do, we need to find for each step the total number of operations needed. So we will simply count it. So for that, counting each for each value in from j till it reaches I, we'll use a variable and we'll store this count plus there, this one. So each time we will just keep on adding this variable until it reaches I. That means if at any point if I is equal to 2, then it will count for all these 3. If I is equal to 2, 1, then it will count for these 2. If I is equal to 3, then it will count for all the elements. So for that it is needed. Now once this count is done, then what we will do is simply assign it to our result set, saying that this is for I minus 1. Since we are starting with I is equal to 1, so we will do with I minus 1, and we will simply store it in count, add it count. And once this is done, then here return response. Okay, so here we need to initialize this count here. So since we are counting for each iteration of I and inner iteration for that means j, each time it will be starting with 0 and it will go up to I. So and that value we are storing it this response array. So we have to initialize each time with 0. We'll simply do long count is equal to 0. So that's it in this coding. So let's try compiling this code. So here we can see we have got our output correctly. So we have found one medium, and for each I, starting j with 0 to that I index, we have found the difference of median and each variable from this array, and we just added those and we have stored in the response array. So it is saying that this 5 for this when I is equal to this here 1. So 5 number of operations will be needed. And suppose the median, as per example, that if we are making it to 4, then for going 1 to 5, 4 steps are needed, and for 1 to 4, 3 steps are needed, and for making 6 to 4, 2 steps are needed. So 3 plus 2, it is 5. So that's why this count is equal to count plus is needed, because for each j we will keep on adding those number of operations until it reaches I. That means for each operation, that is for each index value. So now let's try submitting this solution. Okay, so here we can see we have got some issue there. It is saying the time limit exceeded. This for loop is there and this inner for loop is also there. I think this is making a difference. So somehow we have to optimize this solution. I think this for loop is creating that extra problem. So what we can do, can we see that, can we extract to a formula, can we find out a formula for getting the response out of this approach? So what we can do here, what we are doing here actually, for each value from that array, we are doing this absolute operation of this one, median minus this one. So the middle element of this one, this is done, and that we are adding to count. So if you try to eliminate this, then the response of I, it will be, this part will already be there, but this I operation, this instead of j, I has to come. That means starting from 1, that has to come. But the thing here is that this part cannot, we cannot have this step here. Okay, so here if you look at this clearly in this one, so here it is said that, here it is that for each step, if you can see this output and this input, this input array here, so can we think of utilizing the previous output to get the next value? So something we can we do to a formula through which we can calculate that easily without going to this second for loop again and counting for each step again. See, this count we are doing again and again for each I. That means it would be repeated for even for the previous one. So can we somehow figure out to utilize the previous response for getting the next one? So for this one, what we can try. See here, if we see this, if from this number 6, if I subtract I by 2, I here is 1, I by 2 will be 0. So if I subtract this one, 6 minus 1, that we have got here 5. Okay, 6 minus 1 we have got it 5. Then if you try to use that approach only for the next element, then for 9, from 9 we have got 8 here. So 9 minus 6, see, for getting this 5, what we are trying to find out one formula. So what we are doing here, 6 minus this one, 6 minus 1, that means I minus 1. So that we are, to that we are that from that we are getting 5. For next element, this minus this, that means 9 minus 6, it will be 3 to 8. So if we add 5 to this, then 9 minus 6 plus 5, that will become 8. So here we can even say for 5 also that 6 minus 1 plus 0, that will give 5. So if we subtract 2 element here and add the response of the previous one, then we will get to that value. So here we will see that 12 minus 9, no, so that is not there. So we have to find the median. See, anyway the approach will be same. We have to reach somewhere to the median only. So if we try to find the medial element for this one, so it will be the, here I will be 3 by 2 for this 12 in the position I will be 3 by 2, it will be 1.5, so it will be 1. So this one, so 12 minus 6, so for from this one to get to 12, from 12 to get to 6 operations are needed. And how many steps were required in the previous response? So that were 8. So 12 minus 6 plus 8, that will become 14 here. So what we can do here, so we can first comment this. Actually we are trying to reach to a formula, so for that only we are what we can do, let me comment even this. let me have that above 1. So here what we are doing, this that means if any array of I, a of I, sorry, a of I, if to this one we are subtracting which one, middle of the array for that index I. So middle of the array, how will do there, it will be a of I by 2. Middle of the array, that will be, that's the kind of median only. So array of I by 2. Then to this what we are adding, we are adding the previous response. It will be response or response of I minus 1. Actually this is result variable, so result of the previous result value. So this one, so again we'll just verify. For I is equal to 2, if we divide by 2, that means I is equal to 2 divided by 2, so it will be 1 only. Sorry, here I is equal to 1 by 2, it will be 0. So from 6 we are subtracting this middle of the array, that will be pointing to this 1. 6 minus 1 will be 5. 5 plus 0 will be again 5. Then for when we are taking this I is equal to 2, that means in 9 in reference. So from this 9 we subtract the middle of the element, sorry, the middle of the array element. So here it is I is equal to 0, 1, 2. 2 by 2 is 1. So here what is that array element there at index position 1? It is 3. So 9 minus 6, it will be 3. 3 plus 5, the previous value, it is 8. So okay, so let's try with this approach only, and that we will store in response of I. See, actually the approach is same only, but here instead of calculating this median and all directly and all these things, and we are doing this J operation to count the number of steps, we are just trying to come to a formula so that we can eliminate that time limit exceeded that error. But the approach is still the same. Here also we are trying to reach the middle of the array, and instead of counting this number of operation each time, we are trying to utilize the previous counted variable. That means the previous counted resultant variable. Okay, so with this one, so since we are now not using this, let me first try compiling this code. Okay, so it is saying, okay, so now we are not doing for this one, I is equal to my minus 1, so this equal to is not required. Now with this one, so here, okay, here I should be I, not 1. Wrongly I typed I, sorry, 1 instead of I. So here we can see this time we have got our output. Even last time with this formula also we have got this. Now let's try submitting the solution. Because out of 1100 cases, that means only 5, only the last 5th one had failed for that time complexity. See, but here we can see this time it has passed all the test cases. So now we can simply remove all these, saying that it's not required, and we can just try to use this formula only, which we have just derived from that question, but using the same approach of finding same approach of trying to reaching to the median. So now let's try submitting it again after removing that code. Even this time it will be the same thing, because we have not changed anything, only the commented code we have removed. So here also we have seen that we have got all the cases passed, and so we have solved this problem successfully. So I'll be providing that the link of this question in the description box, so kindly check that. Yeah, so that's all in this video. Please like, comment and share the video, and please subscribe to the channel. Thank you for watching.